Good morning. It is Monday, April 13th. Today we are going to find trig ratios through a point using SOHCAHTOA, the reciprocal functions, and ASTC. Even though this is a one-day lesson, we're going to give you 2 days to complete this. It's just going to be one lesson that I record, but I'm going to give you some time to practice this. It is important every reading to ask a question on this. And it contains, it really combines almost everything we've done so far in this unit. So let's just jump right into an example. The notes are up here. We'll refer back to them as we go through. And it's very similar to the first lesson we did in this unit, the reciprocal trig functions, excuse me, but there's just a couple of little twists that we're adding to that. Everything in that lesson was in quadrant 1. Now we're going to go over the different quadrants. So angle theta is in standard position, and 3, 4 is a point on the terminal side. So 3, 4 would be somewhere here. And just like we did in the first lesson in this unit, I'm going to make a right triangle out of it. I'm going to go from the origin to that point, and then I go down to the x-axis. And the reference angle is always my angle. So if this point is 3, 4, 3, 4, that means that this side is 3 and this side is 4. Basically, this is your x and this is your y. So your x distance is your x value, your y distance is your y value. Now, what's the third side of that? Well, I have to use Pythagorean theorem to find that, unless it's a Pythagorean triple. Is this a Pythagorean triple? Yes, it's a 3, 4, 5. We talked about the Pythagorean triples earlier this unit, 3, 4, 5. 5, 12, 13, those come up the most. Then we also have 7, 24, 25, 8, 15, 17. Also, any multiple of each of these is a Pythagorean triple. Again, if you don't know your Pythagorean triples, this is too sloppy for me. If you don't know your Pythagorean triples, you don't need to know them. You can just use Pythagorean theorem. It's just knowing them is going to make your life faster and easier. So I know mine, so I'm going to utilize that. So now we're going to use SOHCAHTOA. Cosine is A over H. A over H is 3 over 5. Sine is O over H. O over H is 4 over 5. Tangent is O over A. O over A is 4 over 3. Maybe saying, Mr. Schlansky, we learned this lesson already. Well, yes, so far this is the same. It's going to take on some twists in a little bit. So far the only twist is now I'm giving you a point. If it's through a point, again, the x value goes here in your triangle, the y value goes here, and from there it's the same. Secant is the reciprocal of cosine, so I just do the reciprocal of cosine. Cosecant is the reciprocal of sine, so I just do the reciprocal of sine. Cotan is the reciprocal of tan, so I just do the reciprocal of tan, and I get my values. Now, what's new for this lesson as opposed to the previous lesson, I need to look at the quadrants. All students take calculus. This is in quadrant 1. In quadrant 1, they're all positive, so all my values are positive, and I'm done. When I'm not in quadrant 1, you're going to see how that affects it. So that's it for the first example. It's pretty much the same thing that we did in the reciprocal trig functions lesson, but it's going to change as we progress. Number 2, angle theta is in standard position, and 4, negative 7 is on the terminal side. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. 4, negative 7 is there. To make my triangle, I go from the origin to that point, and then it's always to the x-axis. So if this is 4, then that side's 4. If the y value is 7, then the y value is 7. All right, the x is the x distance, the y is the y distance, and because distance can never be negative, I disregard the negative. Now, to find the third side, is this a Pythagorean triple? No. So I'm going to do A squared plus B squared equals C squared. 4 squared plus 7 squared equals X squared. 16 plus 49 equals X squared. 65 equals X squared. X equals radical 65. It's not going to always work out to be an integer, so don't be freaked out if it's not. And if it's a radical, we just leave it as a radical. All right, so Katoa. Oops. Cosine is A over H. Sine is O over H. Tangent is O over A. A over H. 4 over rad 65. Sine is O over H. O over H is 7 over rad 65. O over A is 7 over 4. The reciprocals, I just do the reciprocal. The reciprocal of cosine is secant. The reciprocal of sine is cosecant. And the reciprocal of tan is cotan. Now, that's great and all, but four of these answers are wrong. So if I refer back to my notes here, we're going to plot the point. We're going to make a triangle. We did that. The x and y coordinates are the adjacent and opposite. The radius of the circle is the hypotenuse. We're going to talk about that in a little bit. We haven't talked about that much yet. Use Pythagorean theorem to find the third. We did that. Find the trig ratios using SOHCAHTOA and the reciprocal functions. We did that. 6. The final step. Determine the signs using ASTC. All students take calculus. So let's just talk about what that means again. A means in this quadrant, they're all positive. It means that sine is positive, cosine is positive, tan is positive. That's what the A means. S means that only sine is positive. So sine is positive, and the others are negative. T means tan is positive. So in quadrant 3, tan is positive, which makes sine negative and cosine negative. And C means cosine's positive. That makes sine negative and tan negative. So that's what you need to understand about ASTC. We did a whole lesson on it. It's just saying what's positive in which quadrant. In this question, the triangle is in quadrant 4, which means cosine is positive. So these are good, but everything else is negative. And remember, we said in that same lesson, when I do the reciprocal of something, I don't change the sign. Oh my God, I put the wrong answers there. That's really annoying. Can I undo that? Sorry. Let's back that up. I said the right thing, I just circled the wrong thing. C, cosine is positive. So these are correct, which means everything else is negative. We said in the other lesson that we did that when I do the reciprocal of something, the sign doesn't change. So if cosine's positive, then secant's positive, because when I flip something, the sign remains the same. If sine's negative, the reciprocal of that cosecant's negative, and if the sine of tangent's negative, the reciprocal of that is also negative. So this is definitely new for this lesson as opposed to the reciprocal trig functions lesson. In fact, this is probably the main thing that's different. You have to check the signs at the end. You're going to hear me say a lot. That's great, but we got 4 of them wrong. You have to check the signs at the end using all students take calculus. Let's try another example. All right, I seem to be missing something there and there. So let's just jump ahead to, hold on one moment. All right, just kind of pause it to fix this. So let's try number 3. If that, we're going to skip to one that's later on, and then that's it. You're going to practice, and you'll complete your quiz. Again, they ask on almost every Regency exam, they ask a question on this. So number 3, it's really the same thing that we've just been doing, nothing really new. So this is what I kind of want you to do on your own. I'll kind of talk you through it. But at this point, it's really something you should be doing on your own. It says that angle theta is in standard position and -5, -12. So -5, -12 is somewhere there. We're going to draw our triangle. We always connect it to the x-axis. I want you to fill in whatever values you have there. I'll give you about 20 seconds to do that. The x is 5, so this distance has to be 5. The y is 12. Again, I'm not going to put the negatives in because on a triangle, the distances are always positive. I need to fill in the third side. Is this a Pythagorean triple? Let's see, 5, 12. Yep, 5, 12, 13 is a Pythagorean triple. So I'm going to fill in the 13. And now I'm going to do I'm going to give you about 2 minutes right now to fill in the 6 ratios. You got 2 minutes on your own, fill in those 6 ratios. Okay, let's see if you got it. Cosine is a over h. A over h is 5 over 13. Remember, this is your angle. Sine is o over h, 12 over 13. Tangent is o over a. That's 12 over 5. The reciprocals are the reciprocals. The reciprocal of cosine is secant, 13 over 5. Reciprocal of sine is cosecant, 13 over 12. The reciprocal of tan is cotan, 5 over 12. Great, but we got 4 of them wrong. Why? Because the final step, all students take calculus. In quadrant 3, only tan is positive. So everything else is negative. Now they're all correct. Those are my 6 answers. And that's it. It's not that difficult of a lesson. There's a lot of little components to it. But if you put the time in it, it's really not that challenging. But there are definitely a lot of little components to it. And again, you have your steps here. Let's talk about our steps one more time. We're going to plot the point. We're going to make a triangle by connecting it to the origin and the x-axis, always the x-axis. The angle that we're using is the reference angle. The x and y are the adjacent and the opposite. The x is basically your x distance, your y according to your y distance, which is your adjacent and your opposite. We use Pythagorean theorem or a Pythagorean triple to find the third. We then use SOHCAHTOA to find the trig ratios, and then we find the reciprocal functions by flipping those. Finally, the most common mistake, determine the signs using ASTC, know what's positive in which quadrant and what's negative in each quadrant. And then, as a little side note, know your Pythagorean triples. You don't need to know them. You can use Pythagorean theorem, but if you know them, it just makes your life faster and easier. So there's one more example that I want to do. And then we're going to move on. Well, we're going to be done by move on. So, circles with this. A circle centered at the origin has a radius of 10. So this is not the unit circle, but it's kind of like the unit circle. It's a circle centered at the origin, but the unit circle has a radius of 1. This particular circle has a radius of 10. The terminal side of angle theta is in quadrant 2. It says point C. There's my triangle. It says the y coordinate is 8. What is the value of cosine? Well, as of right now, I don't have enough information to do Pythagorean theorem because I only have one side. Well, I actually have 2. And if I look back at the notes, did I put it in the notes? I don't know if I did. Yes, I did. The radius of the circle is the hypotenuse. So let's use a little bit of geometry here. Yeah, geometry. We all remember how great that was. If the radius of the circle is 10, then the distance from the origin to any point on the circle is 10. The radius is the hypotenuse of your triangle. Now that you have that, you have enough information to find the x value. This is a Pythagorean triple. Again, if 3, 4, 5 is a Pythagorean triple, then any multiple of that is also a Pythagorean triple. You could do Pythagorean theorem. I'm not going to. And now it's just asking for cosine. So I'll use SOHCAHTOA. I don't have to do everything. Cosine of theta equals A over H. Cosine of theta equals A is 6, H is 10. And that's great and all. I don't see that. I do see them reduced though, so I can reduce that to 3 over 5. But I really hope you don't circle choice 3 because choice 3 is not the answer because there's one more step. Again, the most common issue students have is they don't do the final step, which is to check the sign. All students take calculus. In quadrant 2, sign is positive, which means everything else is negative. Your answer is choice 1. It's the same procedure for all of them. It's a little bit longer. Again, if they tell you the radius is the hypotenuse of the triangle because the hypotenuse of the triangle is a radius. Otherwise, if they give you a point, then your x is your x or your adjacent, your y is your y or your opposite, and then again we can use Pythagorean triples or Pythagorean theorem to find the third. From there, we use SOHCAHTOA, we use our reciprocal functions, and then more importantly, we check all students take calculus to see what's positive and what's negative in which quadrant. Your classwork/homework is to finish, I think, what was the name of it, trig ratios through a point. And your quiz will be due to, your quiz should be due tomorrow, but I think I'm giving you an extra day and everything just to be a little extra lenient for those of you who have a lot going on. You will not have a new lesson tomorrow. Tomorrow you can continue practicing this lesson. And that's all I got for you. Enjoy the rest of your day. Stay safe. And I'm looking forward to seeing you guys. I miss you guys. It's been tough without seeing you, especially since I haven't really seen you since January. All right, guys, be good. Have a good day. Any questions, reach out to me and remind.